Hello and welcome again. In this lesson, we continue from where we left off in the last lesson, looking at the relative atomic masses as given in the periodic table. And you would remember that something like carbon has a relative atomic mass of 12.01. This is arrived at because of the relative abundances of the various isotopes. And you'd remember the example with chlorine, where we arrived at 35.5 as the relative atomic mass of chlorine. This relative atomic mass is given this abbreviation here, A with the subscript R. And the AR of any atom gives the mass of 1 mole. And that's where we'll begin today. So the AR is given in the periodic table. For something like carbon, 1 mole of carbon atoms is 12.01 grams. Those 12.01 grams make up 1 mole of carbon atoms. So that's why we can give this unit grams per mole. Notice I'm saying per mole and I've got the -1 here because grams divided by mole can be expressed in this way as well. Grams mole -1. 12.01 grams per mole. That is the mass of 1 mole of carbon-12 atoms. And if you had 1 mole of carbon-12 atoms, you would actually have 6.02 by 10 to the power of 23 atoms in those 12.01 grams. The Avogadro's number represents the number of entities that make up a mole, whether that be electrons or ions or atoms or molecules or whatever it is. The mole is actually a unit that is used to quantify things that are very, very abundant or plentiful, which would be things like atoms and electrons and things of that nature. Because if you look, 10 to the power of 23, it's a number that's beyond our conception really, and it's really designed to quantify really large amounts. The question that bothers a lot of students though is, where is this Avogadro's number coming from? And there's a lot of misconception surrounding that and a lot of confusion, and it's not required in our course that we go into how the Avogadro's number is derived. In fact, a lot of sources would tell you it has to do with the work of Avogadro, and that is not even correct. But we're not going to go into that, how the mole was derived. It is simply a unit, and that unit is made up of 6.0 by 10 to the power of 23 of anything. And if I asked you to give me 1 mole of carbon atoms, you would go to the periodic table and check the relative atomic mass of carbon. And then you would bring me 12.01 grams and say 12.01 grams makes up 1 mole. So that is what we would call the relative atomic mass of carbon. If I asked you to go and give me 1 mole of hydrogen, you would go to the periodic table and see that hydrogen is H, but hydrogen gas is H2. For chlorine gas, it's Cl2. So you would take the relative atomic mass of chlorine or of hydrogen, multiply it by 2, and you would be getting the relative molecular mass of H2 or Cl2 gas. In the case of chlorine, it would be 35.5 multiplied by 2. So you would be bringing me 71 grams of Cl2, and that would be 1 mole of Cl2. That would be made up of 6.02 by 10 to the power of 23 molecules of chlorine. And it would be made up of 6.02 by 10 to the power of 23 multiplied by 2 atoms of chlorine, because each molecule of chlorine is made up of 2 atoms. Similarly, if I asked you to bring 1 mole of carbon dioxide, you would go into the periodic table. You would get 12 for the relative atomic mass of carbon. You would get 15.99 for oxygen. Multiply that by 2 and you'll get 43.99, approximately 44 grams, making up that 1 mole of carbon dioxide gas. And that, of course, is what we would refer to by this abbreviation, M subscript R. That is the relative molecular mass. These are all molecules. But what about if we have something that's a formula but not a molecule per se, like an ionic compound like calcium carbonate or calcium sulfate? In that case, we don't use the term molecular mass, but we say the relative formula mass. Use the same abbreviation, but we use the term the relative formula mass. A subscript R, relative atomic mass. When we're dealing with molecules, we say relative molecular mass. And when we're dealing with something that doesn't really exist as a molecule, like an ionic compound, which exists as something called a crystal lattice, then we would use the term formula mass, but the same abbreviation, M subscript R. And to find the relative formula mass of something like calcium carbonate or calcium sulfate, you go to the periodic table, and in that periodic table you'll be checking for the atomic masses, first of calcium, 40.1, carbon, 12.01, oxygen, 15.99, and you'll have to multiply that by 3. That total would come up to 100.1 grams per mole. So this here would have to be multiplied by 3, and then the total comes up to 100.1 grams per mole. Notice the unit? That is the relative formula mass of calcium carbonate. Now, all of this information is going to be useful when we move on to the topic of stoichiometry, which is looking at how we can use balanced equations to predict the amount of product that we would get from a particular chemical reaction.